Okay guys, today we're going to explain you how to use this circuit simulator. This is the PHET circuit simulator. I'm going to show you the basics. These are the batteries. The batteries give the voltage, the potential difference to the electrons so they can move over the circuit. I will show you the basics on how to measure, how to put the things, and then you have to construct some circuits of the guide that I left you in the classroom. So, if you see, every electric component has two pins, has one positive pin and one negative pin. That will shows the direction of the electron. Will, I don't know, will create the movement of the electrons. So the wires help us to transport the electrons so they can reach the other components. So I'm going to put this resistor. Generally the circuits are made, you have to make it forming squares because that's easier to understand. So try to do it like I'm doing right now. With this, I'm going to put a resistor, only a resistor, and then I'm going to connect the wires and see what happens. If I connect the wires, the difference of potential is created among these devices, and then the electrons can flow. It's important to know that if you choose a very low resistance, you make a short circuit. This happens when you connect directly the positive terminal with the negative terminal. So I can choose the resistance of this resistor. Notice that the colors change as long as I change the resistance. This is a code for easy identified of the resistors. Okay, so if I want to measure the voltage of this resistance, I need to take an advantage of that the voltage is the same in parallel. So I will measure this voltage in parallel. And because it's only one resistance, all the voltage of the source is now in the resistor, because in some certain way this resistor is in parallel with this battery. Yeah, it's hard to see like this, but if I put this circuit maybe like that, no, I can put it easily. Maybe later I will explain that. So continue. This is the voltage that is in the resistance. So the voltage is measuring in parallel. Now, if I want to measure the current, I need to cut one cable because the current is measured in series. So I need to connect this ammeter to the resistance in series. The only way to do that is with cutting the resistance. So I cut the wire, then I have to connect it again, and then I got the ammeter with the voltage, with the resistance. So if you calculate this using the Ohm's law, if you divide 9 volts over 60 ohms, you get 0.15 amperes, following the Ohm's law. Now, let's see what happens if I connect another resistor in series with that. And then when I'm going to put another ammeter, and then I'm going to loop the circuit, because if I don't loop the circuit, this won't work. Now the current is different because I add another resistance, and as you should know, if I keeping adding resistance in series, the total resistance will increase, so the total current will decrease, as the Ohm's law states. But the total voltage won't change because the total voltage depends on the source. So if I measure this voltage is 9 volts. If I measure the voltage on the resistance is 7.71 volts, that means that this resistance is higher than this one. Let's see, this one is about 10 ohms, so its voltage is less. If I get negative numbers, it's because I'm measuring backwards, so you can switch it and then obtain positive values. If you change this voltage, this resistance, following the Ohm's law, this voltage should increase. But as this voltage increase, this voltage should decrease, because the total voltage must be the addition of this voltage with this voltage. So if you add this voltage, then you find the total voltage that is given by the source. And if I increase the resistance of one of them, look at the current, it will decrease. And other important thing is that something is happening, that the current is the same. That is a property and a special property of a series circuit. So now you know how to measure, now you know how to put. The main idea is that you simulate some of the circuits of the guide. At the end of the guide, there's a lot of exercises. Choose at least 3 of them and simulate them with this simulator. Thank you very much.